What's going on, everybody? It's Nick from Archangel Battery here, back at you with another video. Going to make this one quick. This is really more of an addendum or an addition to the last video I did discussing if lithium batteries would burn up your alternator without modification to the alternator itself. So I just wanted to give a little bit more explanations on their arguments, Victron Energy's arguments, and without further ado, let's get into that video.
Okay, so back to the video. I just wanted to re-go over this point. I don't know if this is the exact spot in the video where it exactly happened, but I just kind of wanted to give a better version of their argument because I didn't feel like that I represented them very well. All of my points are still correct, and I'm still going to leave the video up, but I just wanted to do a rehash over this one point, kind of explain better what they were talking about and why I still disagree. So let's get into it.
The next test we conducted was charging the battery at half the speed, 1500 RPM. Note that this is still above the typical speed of an engine running idle.
Oh, and I did want to explain real quick. So if you don't understand how an alternator works, I just kind of want to go over the basis of how it works. So basically you have a prime mover, aka an engine, a gasoline engine in this case. In the case that I want to describe, like the Ram 1500, for example, that I had alternator tables for. So basically what happens is the prime mover, or the engine, turns a rotor. That rotor has magnets on it, essentially. It has coils of copper wire, and whenever you pass a current through those, it creates a magnetic field. And magnetic fields are then turned by the prime mover, and they start revolving. And when they revolve, you create a revolving magnetic field. And then when you have another set of coils, aka the stator, the stationary set that's inside the alternator, inside that revolving magnetic field, they get a current induced in them, and also a voltage, of course. And so that's how an alternator works. And then it comes off that stator. You have actually three-phase power coming off that stator on the alternator, and then those are ran through diodes, which don't allow flow. They only allow flow in one direction, basically. And it's basically a rectification circuit. So if you want to look into that, you can look into that. That's getting way too complex for this video, but it's basically a rectification circuit. Basically, what that means is it takes AC to DC. There's usually some kind of smoothing, I would assume, with capacitors. This allows you to kill any ripple, because typically when you rectify, you'll have still some kind of a little bit of a waveform coming out of there. You usually want to rectify that. I know it's regulated, which basically means it shuts the voltage off to 14.6 max in the case of alternators. And the way alternators kind of control things is they control it through voltage regulation. So the max voltage they can go up to is 14.6. Typically when you're charging a battery, you're going to do constant current, constant voltage. So what does that mean? That means your alternator will put out as much current as the battery can accept, and it will vary the voltage, increase the voltage until it gets to the point where it hits what we like to call absorption mode, or CV, or constant voltage mode. At which point it holds your voltage constant, in this case probably at near max on the voltage regulation, so 14.6 usually, something around there. And then it tapers the current down to wherever it needs to be to maintain that voltage. So that's kind of how a alternator works and the gist of it. If I made any mistakes, please correct me. I tried not to. Let's move on.
This test is still pulling a similar amount of current, 65 amps, out of the alternator, but the effect of the lower RPM and therefore less cooling on the alternator is significant. Its temperature increased so much it started to burn the internal coil.
Okay, so what their point behind this is, and the whole reason behind this video, and I'm pretty sure I'm at the wrong spot, but the whole point behind this video is that they're trying to say that lithium batteries have a much lower resistance, and therefore you're going to have to put much higher current into them for a much longer time, thus burning up the alternator. I have several problems with this. One, alternators, like I mentioned in the video, have a safety rating, which means they can go well beyond what they're rated for extended periods of time. Secondly, they're hooked into a vehicle, so they have heat sinking. Thirdly, so alternators, basically the way this works is your battery will have an acceptance rate. So if your battery is deeply discharged, like the battery they have in this one at 50% SOC, actually I wouldn't call that deeply discharged, it's discharged to 50% SOC, your alternator will have to charge the battery. Now, the further discharged you are, the more charging current your alternator will have to put out to charge that battery, which means the acceptance rate, quote unquote acceptance rate, of your battery is much higher. Meaning your battery can take more current from the alternator. If your battery's current acceptance rate is higher than that of your alternator will have to put out a lot more current at a lower voltage and then increase the voltage slowly until it gets to that max voltage point, constant voltage like I was talking about before, and then it can start to drop the current and bring it into a range that it can maintain that voltage at on the battery. Basically, when you're putting current into a battery, you're increasing its SOC slowly, and SOC in lead acid batteries is typically estimated through voltage. So the higher your voltage, the higher the SOC you have on that battery. In reality, and in lithium batteries, because the discharge and charge curves are so flat, most of your SOC in a lithium battery is contained at around 13.4 volts. So voltage estimation is terrible, and you have to Coulomb count, and that gets into a whole bunch of other stuff, and I don't want to get into all that. But I say all that to say, basically their argument is this. Because lithium is lower resistance, there's less resistance stopping current from flowing into the battery, and so you're going to have a much higher acceptance rate on a lithium battery, and that acceptance rate is going to outstrip your alternator, and therefore, because it's outstripping that alternator and it's outrunning that alternator, you're going to be putting out current, a much higher current than that alternator is in what they're claiming is designed for, and therefore it will burn up your alternator. Now, this is not what you see experimentally. This is not what like I said, it doesn't, there's BMSs involved that disconnect from the circuits, allow for cooling. There's a heat sink, there's a huge heat sink involved. There's also the fact that lithium batteries will actually charge faster, so its SOC will go up much quicker than that of a lead acid. So if you were to actually charge at a higher current, that lead acid's SOC is going to get up there real quick, and so is that voltage. And once that happens, it's just going to go into constant voltage mode and start tapering the current like it would with a lead acid battery. Because typically in cars, the bulk charging phase, or the constant current phase, like I was talking about before, it almost gets skipped because batteries in cars are very small and they don't have a lot of capacity in it of themselves. And so when they get charged real quick. And that's why you see on your cars, you typically see that 14.6 show up really quickly. And that's because cars don't have a whole lot of capacity, so it doesn't take a whole lot to charge them. So a lot of times it skips that bulk charging phase and goes straight into absorption phase, which is your constant voltage phase. That's what it does with lithium, except it does it even faster. So I'm not really seeing their whole point here, and I'm going to attach a video where I actually show, after I've started the car, what the current being charged or drawn from the battery is, and you can kind of witness that live. It's not the most accurate meter. It's a little Ames meter that I purchased from Harbor Freight, but nonetheless, it kind of shows experimentally what actually happens in the real world, as opposed to the testing that they're showing here, which is kind of set up to induce a failure so that they can sell an alternator. Anyways, that's kind of all I had for today. It wasn't going to be really a big video. I did want to mention, I didn't pull it up, and I should have pulled it up. In fact, let me pull it up right now. Sorry, guys. Let's search for, because these people say similar, and I want to see if I can find it, because yes, here it is. So let's see. Here's the part. So these people say similar to Victron. This is interesting right here. Even they admit it. It is interesting to read some reports from people that have charged their lithium battery directly with non-regulated alternators for years and never had a problem. My guess is that their charge circuit has a high enough resistance that it limits the current. Okay, even the people who are selling this to other people don't 100% believe in what they're saying. They're basically saying, look, this doesn't happen experimentally, but still, buy our stuff. Guys, this doesn't happen. There is no problem with running a lithium battery in a car with no modifications. I'm sorry, there's no issue with this. Anyways, just wanted to mention this real quick. I didn't feel like I gave their argument a good enough explanation. I wanted to give a better explanation. I feel like I've given that now. If you want to stick around for the end of the video, I'll be actually showing, like I said before, the current in and out of the battery, or rather, yeah, however you want to define it. It depends on if it was charging or discharging at the time. You can kind of see that. It's very low. It's actually lower than I thought it would be. And yeah, that's it. Anyways, if you like this video, please like, comment, and subscribe. And I'll see you on Friday. Thanks. Bye.
Shows only 4 amps. This is at idle. I'm not seeing a smoking alternator. This is with lights on. This is with AC on. I'm giving it all the chance in the world.